Now that we have discussed about remainder theorem and its significance in finding the remainder in dividing the two polynomials, let's try to take that concept more further. Remainder theorem also helps us not only about finding the remainder but also in verifying for the factorization. If I would like to check for a linear polynomial to be a factor of the given polynomial p of x, I can simply do that also equally using remainder theorem. So let's see how we can use remainder theorem in factorization. Remainder theorem versus factorization. It's very simple to understand the factorization using remainder theorem. So let's see how we can connect factorization with remainder theorem. As we have discussed about remainder theorem, let's recap the definition or the statement of the remainder theorem back again. If a polynomial p of x is divided by a linear polynomial x minus a, it gives us the remainder p of a or f of a, is what we understand. If I get the remainder to be 0, then let's see what will be the special case. If p of a is 0, that is a is the 0 of the polynomial p of x, 0 of the polynomial p of x, which gives us a different concept of understanding the factorization. Therefore, if I have a special case which says p of a is 0, that is with the condition that the remainder is 0, that is when the a is the 0 of the polynomial p of x, then simply when I substitute this value in the remainder, I get remainder as 0. And when the remainder is 0, it comes under special case in the remainder theorem. So in the special case of the remainder theorem with remainder 0, that implies I say this x minus a is a factor of p of x. It acts as the factor of the p of x. X minus a is a factor of p of x. It exactly gets divided with the polynomial p of x. Is how we understand the factorization, then condition related with the remainder theorem. Is how I understand the factors connected with remainder theorem. Now let's take an example problem to understand the concept more better. Remainder theorem versus factorization. If I have a question which says, is x minus 3 a factor of p of x equals x squared minus 5x plus 6. I have a question here which says, is the linear polynomial x minus 3 a factor of p of x equals x squared minus 5x plus 6? Then how do we continue with? Of course, with the remainder theorem. Remainder theorem not only helps in finding the remainder, but also in identifying or justifying whether a given linear polynomial is a factor or not a factor of the given polynomial p of x. So let's see how we can do this with an example problem. As I have the given polynomial to be p of x equals x squared minus 5x plus 6 and my linear polynomial which is x minus 3, I clearly see the condition 1 of the remainder theorem which says the degree of p of x is 2, which is not equal to 0. The condition 1 where the degree is non-zero. And the second thing I find here is my x minus 3 when compared with the factor x minus a clearly says that my a is 3, which belongs to real numbers. So degree being non-zero and the value a belonging to set of real numbers is what is the condition for existence of remainder theorem. Now with these two conditions, let's see what is the remainder for the given polynomials divided one by the other. By remainder theorem, which we have already discussed in the session, if the polynomial p of x is divided by x minus 3, that implies the remainder is f of a or p of a, which is 3. Let's see what is the value of p of 3. P of 3 is when we substitute the value of x equal to 3 in the polynomial in the left side equally on the right side with 3 squared minus 5 times 3 plus 6, which on further simplification gives me 9 minus 15 plus 6, which is 15 minus 5, which is equal to 0. Therefore, my remainder is, when we cancel, I get as 0. Therefore, the remainder is 0. So when the remainder is 0, we have already discussed in remainder theorem connecting with factorization that if the remainder is 0, then the given divisor is a factor or a pure factor of the given dividend. Therefore, x minus 3 is a factor of p of x. It exactly divides is how we understand x minus 3 is a factor of p of x. Is how we conclude the remainder theorem with factorization. Remainder theorem also helps in finding factors and helps in finding the remainder. So let's see what are the factors for this given problem. So when I have the polynomial p of x, when divided by x minus 3, I have my p of x, which is x squared minus 5x plus 6 by x minus 3, which is x minus 2 times x minus 3. This polynomial is a quadratic polynomial or a quadratic function which can be expressed as factors by using factorization. When I factorize the quadratic function, I get the factors as 2 and 3, and therefore this can be written as x minus 2 times x minus 3 by x minus 3. It gets cancelled because it's a factor. And why is it a factor? Because it satisfies the remainder theorem with factorization. Remainder is 0, and hence because the remainder is 0, the two factors get cancelled. That means x minus 3 is a pure factor of the given polynomial p of x, and the result is x minus 2. Is how we understand the complete concept of remainder theorem connected with factorization.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.